GTFS, or General Transit Feed Specification, is the only worldwide standardized format for public transit schedule data. It includes the stops, the lines, the schedules, and some other information. In this section, we're going to talk about the basic components of GTFS data and how it relates to maps and the ArcGIS workflows we'll be talking about in this video series. If you already have a good understanding of GTFS data, feel free to skip ahead to the next video. A GTFS dataset is a series of comma-delimited text files with a specific schema. The files are related to one another by ID fields. Here on the slide, I've listed all the files. Some of them are required and some of them are optional, so you won't see all of them in every dataset. The files in the first and second columns are the ones that are most relevant for the analysis we're going to be talking about in ArcGIS. The ones in the third column are less relevant, so I won't talk about any of them in any detail. I've included a link to the GTFS reference guide and documentation in the slide. I'll start with the first column, stops, routes, trips, and shapes. These files include the geographic components of a GTFS dataset and a representation of how vehicles travel through the system. In a later video, I'll show how you can use these files to display your transit stops and lines in a map using tools provided in ArcGIS Pro. The stops.txt file defines the transit stops. It includes the latitude and longitude of each stop, as well as some other useful information. I've listed here on the slide the most important fields in the stops.txt file. There are several other fields included in the stops.txt specification, but they aren't relevant for the current discussion, so I'm not going to talk about them. The stop ID field uniquely identifies the stop. Stop lat and stop lon define the latitude and longitude of the stop. Location type indicates whether this is an ordinary stop, a larger station, a station entrance, a boarding area, or some other generic node. If the stop is located inside a larger station, it might have the ID of the parent station. It might also include the wheelchair boarding field, indicating whether wheelchairs are able to board at that stop. A GTFS route is something like bus 10 or the yellow line, the type of thing that passengers typically think about. Within GTFS, it isn't actually a geographic concept, it's more like a category. Routes can branch, so for example, half the subway trains for a route might go to one end station and the other half might go to a different end station, but it would still be considered the same route. A route can also define both directions of travel. The route ID field uniquely identifies the route and relates it to the other GTFS tables. The other field relevant to us is the route type field, which indicates the mode of transit represented by the route, such as bus, subway, ferry, etc. Each row in the trips.txt file describes a single instance of a vehicle traveling on a route. For instance, a trip is associated with a route ID, but it always visits the same sequence of stops at the exact same time on a particular schedule. For example, a trip could be an instance of a subway train traveling on the yellow line, visiting these particular stops shown in the slide at these specific times, and going to this designated end station. It would be a different trip that visited the same sequence of stops at a different time of day, went to the other end station, or went in the opposite direction. Like routes, trips don't contain any inherent geographic information. They're also sort of a category, but a category with a finer level of detail than routes. Some relevant fields in trips.txt include trip ID, which uniquely identifies the trip, route ID, which relates the trip to the route it belongs to, shape ID, I'll talk about that in a moment, service ID, which relates it to the calendar.txt and calendardates.txt files that contain information about the days of the week and dates when the trip runs. The wheelchair accessible and bikes allowed fields indicate whether wheelchairs and bikes can be accommodated for this trip, which is often a factor of the particular vehicle that's being used for the trip. We talked about routes and trips, and I mentioned specifically that neither of those contain any geographic information. At this point, you're probably wondering how to show your transit lines in the map, and that's what the shapes.txt file is for. The data in this file describes the actual geographic paths through the system traveled by the transit vehicles. A shape represents a unique sequence of stops, so it's sort of like a trip, but it's not specific to a time of day. A route can have multiple shapes associated with it. If you remember our example of the yellow line from before, the yellow line would have two shapes, one associated with the path to each end station, It would probably also have two more shapes representing travel in the opposite direction for each of these cases as well. Within the shapes.txt file, the shape ID field uniquely identifies the shape and relates it to the trips.txt file. The rest of the information is a sequence of point latitudes and longitudes that define the shape's geometry. Shapes allow you to visualize the transit system's routes, but they aren't really directly related to the schedules. I would definitely say their primary purpose is visualization and not analysis. It's also important to note that the shapes.txt file is optional. Not every dataset has it, and in my experience, they are often not all that accurate or clean, even if they do exist, because they're often created from somewhat messy GPS tracks from vehicles. If your dataset doesn't have a shapes.txt file, you can't really represent the transit lines easily in ArcGIS, except by creating straight line connections between connected stops that don't necessarily follow the underlying streets. We do have a couple of tools that help you generate a new shapes.txt file by estimating the on-street paths using Network Analyst. I'll talk about that in a later video. Now I want to talk about the files in the second column. Calendar, calendar dates, stop times, and frequencies. These files describe the transit schedules. In a later video, we'll see how to convert these files, as well as the files in the first column, into the Esri Network Analyst Public Transit Data Model, which can be used to analyze the frequency of public transit service and to model travel by public transit using the ArcGIS Pro Network Analyst extension. The calendar.txt file defines regular public transit service on ordinary weekdays. The service ID uniquely identifies the pattern of service and relates to the other files. The weekday fields like Monday, Tuesday, etc. define whether this service ID runs on that particular weekday. For example, you might have one ID for weekday trips and one for weekend service. The start date and end date fields define the overall date range during which that service runs and is valid. The calendar dates.txt file defines exceptions to regular service. It adds or removes service on specific dates, such as for holidays. The file includes a service ID which relates back to the calendar.txt file and to the other GTFS files. It also includes the date of the exception and whether service is added or removed on that date. Note that both this file and the calendar.txt file are optional, although the dataset must have at least one of them to be valid. Some datasets include only calendar.txt and do not define any exceptions to the regular service. Other datasets don't define any regular service, instead defining everything as a special exception. Both of these are valid ways to construct a GTFS dataset, and this won't matter very much for your analysis since our tools are designed to handle all of these situations. However, it's good to examine your data in advance because some of the choices you make in your analysis might depend on how your data is set up. I'll talk about that more later when it's relevant. The stoptimes.txt file defines every time of day that a stop is visited. This is how both the times of day and the sequence of stops is defined for trips. There are several relevant fields. Trip ID relates back to the trips.txt file. Stop ID relates back to the stops.txt file. Stop sequence defines the order of stops along this trip. Arrival time and departure time define the time of day the stop is visited. Shape disk traveled relates to the shapes.txt file, and it's used when rendering partial shapes in, say, a journey planner. Note that the arrival time and departure time fields can have null values. Some agencies choose to define the arrival and departure times only for time points, and all intermediate stops are not listed exactly. This is a valid way to construct a GTFS dataset, but it's a bit annoying for analysis because if you look at the stop by itself, you don't really know what's going on. But that's okay. Our tools have a way to interpolate the arrival and departure time values if they're missing. More on that in a later video. The frequencies.txt file is a more compact way of defining stop times. It's used to define repeating trips with the same pattern, so stop sequence and travel time between stops are the same. The file just defines a time window when the service is valid and the headway between trips running with this pattern. This file is optional and it's used in conjunction with stoptimes.txt. This concludes our discussion of the parts of a GTFS dataset relevant for public transit analysis in ArcGIS. In later videos, we'll see how to use this data in ArcGIS Pro for visualization and analysis, And we'll also see some ways to edit or create the geographic components of a GTFS dataset.